This is Mr. Beck Does Your Homework. This is AP Physics Homework 2.7 on projectile motion, questions 3 and 4. Question 3 says, an artillery shell is fired at an angle of 82.8 degrees above the horizontal ground with an initial speed of 1,630 meters per second. The acceleration of gravity is 9.8 meters per second squared. Find the total time of flight of the shell, neglecting air resistance, answer in units of minutes. So we've got to be careful about that. Then it says find its horizontal range, neglecting air resistance, answering units of kilometers. So let's be careful of those. So let's see what I know. I've got an artillery shell that's going to be fired up, and it's going to come back down. This initial velocity I have is 1630, and that's 82.8 degree angle. So I know I've got an x world, and I've got a y world. In my x world, my acceleration is 0. In my y world, my acceleration is g is negative 9.8 because it's down, meters per second squared. I know that I'm shooting here at an angle, so my x velocity is going to be the x component of this. The x component of this is going to be given by this velocity, this monster velocity, times the cosine of the angle, because this x is the adjacent side and this y is the opposite side, so the y has to do with the sine. So my initial velocity in the y world is going to be that velocity times the sine of theta. So in the x world, my velocity is 1630 times the cosine of 82.8. My y world, my velocity is going to be 1630 times the sine of 82.8. So that'll give me my initial velocity in the y world and my initial velocity in the x world. That's all that I've gotten here. So now I've got to find the total time of flight. Well, the total time of flight is usually a y world problem. Do I have enough to give me a time? I have an initial velocity, I have an acceleration, I'm looking for a time. That's only 3 variables. Usually I need to find 4 to get one of my equations. But if I go up and come back down, I know that my displacement in the y world is going to be 0 meters. So now I've got enough to solve it, because I can say that my displacement is my initial velocity times time plus 1/2 my acceleration times time squared. So I've got 0 equals v0t plus 1/2 gt squared. This can be rearranged as v0t equals 1/2 gt squared, negative, because I moved this one over to that side and flipped them. So v0t is negative that, but now I've got a t here and a t squared there. So if I divide both sides by t, there's a little trick to get rid of that one. So I get my initial velocity. My initial velocity equals negative 1/2 gt. So twice my initial velocity divided by g, negative 2 v0 over g is going to give me my time. So now I can just plug in this initial velocity, 1630 sine 82.8, in here, and that will give me the time of flight up and down. Negative 2 initial velocity divided by gravity. Now it says find its horizontal range, neglecting air resistance. Oh, sorry, take that time, and that's going to be in seconds. So whatever that is, divide by 60, and that'll give you minutes. Okay, so that many seconds divided by 60, put it into minutes. So that's going to be your answer. The other one says find its horizontal range. Well, I know that in the x world, my distance is just going to be my velocity times my time. Now that I know my time in seconds, I'm going to take my velocity, which is going to be v cosine theta, which is going to be 1630 cosine 82.8. I'm going to take that, I'm going to multiply that times my time from over here in seconds, and that'll give me my time, that'll give me my displacement. Now that'll give me in meters, okay? So that will give me a certain number of meters, and in order to get that into kilometers, you're going to have to take that times, let's see, 1,000 meters is the same as 1 kilometer. So meters will go away. So you're dividing by 1,000, and that will give you your distance in kilometers.